Welcome to the Technical Steering Committee meeting for the EVerest project. As there might be competitors in this meeting, I'll just briefly show this antitrust policy. And then let's begin. On the agenda today, first I'll give you a quick introduction and recap what EVerest actually is. If you've seen this already in the past, you can just jump forward in the chapter marks if you're watching this video. Then I will tell you what's new in EVerest, what's next, and in the end we can have an open discussion if you have any questions, feature requests, or just open discussion points. So, what's EVerest? EVerest is a part of the Linux Foundation Energy. The Linux Foundation Energy is a group of industry leaders and the Linux Foundation that came together to create a new software ecosystem for the green electric grid. And EVerest is a core component for everything relating to electric vehicle applications. Why do you need something like EVerest? The problem in the charging infrastructure industry these days is that it's quite a fragmented industry. It's quite complex. There are a lot of protocols that you have to have available that you then also need to implement correctly, and that can lead to a lot of inconsistencies between vendors, but also a lot of inefficiencies in implementing if everybody has to implement the same protocols all over again. And these inconsistencies can also be a leading cause for poor customer experience due to compatibility issues and things like that. What's EVerest? It's a versatile software stack that you can use for any kind of private or public charging point, be it an AC or a DC charger. And you can also build quite complicated things like distributed charging parks with it, and have software in the loop testing for a lot of the components. EVerest is basically at the center of everything that you need to communicate with a car, but also with adjacent things like home solar systems or cloud and payment management systems. Think of things like OCPP, things like that, and get all the information to the user via APIs to drive user interfaces as well. And obviously, we could have just also started and think about creating a new standard, but usually that only leads to there being yet another standard that nobody really implements that well. So we kind of set us the goal that we want to be a standard compliant open source implementation of as many of the related standards as possible that can then serve as a de facto standard. If you want to play around with EVerest, there's multiple hardware options available. One of them would be the Pionix development kit that consists of a high-level board that uses a Raspberry Pi for a compute module, has bright screen and things like that. There's also a power board available that you can use to build a 11 or 22 kilowatt AC charger, and the hardware designs for this development kit are fully open source. It's a complete open hardware design with reference hardware and firmware available on our GitHub. But there's also a lot more hardware available. There are boards from ChargeByte. There's a development kit from Phytech and Texas Instruments. New, there's also a hardware that's called Recharger from Seed Studio that is powered by BeagleBoard and runs EVerest. And we also have support for things like the Lumicil PLC modem chip. And since we're so central in talking with all these different components regarding EV charging, we're also part of a broad community, talking with all kinds of different partners like standardization bodies, academia, research, also component suppliers, charging station, OEMs, and mobility service providers. So let's jump right in. What's new this month? Due to numerous requests, we've updated the README of the reference hardware with wiring diagrams to better describe how you can build an AC and DC charger with these with these hardware designs, and you can find the updated README on our GitHub page here. As I've already mentioned earlier, there's now a new charger hardware available that runs EVerest. It's a recharger from Seed Studio, and this was introduced at the Embedded Open Source Summit 2023 in Prague, and it's very exciting that there's now even more hardware that can run EVerest out there in the wild. So on the OCPP side of things, we're hard at work implementing OCPP 2.0.1. Our device model implementation is now more or less finished, which makes it quite easy to add and remove new components and variables to OCPP. And we also have support for different database backends for that. And there's also some new functionality since we're working towards having a core implementation ready soon. We now have support for remote start and stop messages, the authorization cache, undock connector, and firmware update. For ISO 15118, we added high-level communication pause and resume to the EVseV2G and the PyJosev module, which has also been added to the CarSimulator for testing, but we couldn't really test it with a real EV yet. There's also ongoing work on the CarSimulator regarding ISO 15118-20 AC and ongoing refactoring of this car simulation with an upcoming EV manager as a counterpart to the EV manager. Now I will hand over to Moritz from ChargeByte.
Yes, thank you. Just for the ChargeByte contributions, there's not a lot of changes to report this month. The EVseV2G module, there was a fix for the timeouts and authentication because they are not noticed anymore. They are not, timeouts aren't being signaled to this module, so that has had to, or failure to authenticate, so it had to introduce its own timeouts. I believe that has been merged. And on the next slide, the contributions for the EXI Codec Generator. We're still working on various grammar fixes. I found another small issue today, which I already fixed, which I'll be making a pull request for in the next days. We've also found another user of the codec. They're planning to use it in their products, and we're looking for an open source solution. And they went through a lot of testing and gave us some feedback on that using real streams. They started off with Dean and ISO-2, and they had some issues there. We helped them with some of those issues, and they may have found some corner cases as well. So we're integrating those into our test flow and checking whether it aligns with the bugs we've already identified and are fixing right now, or whether there are more bugs which need to be fixed, major or minor ones. Probably minor ones, things we missed on the way. From the same team, we're hoping that, well, they are hoping to use this codec for -20. They're testing the -2 and the Dean just for getting a feeling of the maturity of the code generator, and we hope to get some -20 feedback from them as well when they start integrating or using test streams from commercial testers, things like that. And of course, I'd like to emphasize again, anyone who's begun using real ISO 15118-20 streams already has something running or has been at a testival and was able to capture some of those. We are eager to see those to understand whether we can decode them, because we're pretty good on the way for the AC, DC, and the common messages, and we'd like to have more. We'd like to be more safe on those. So another appeal for some contribution here. That's it from ChargeByte. Thank you.
Thank you. And let's quickly go over some of the other changes in the last month. From the framework side, we are still working on the remote requirements and the improved error handling and reporting. This will probably be merged within the next month. And we probably already talked about this like last month. Modules will now be able to raise errors and handle errors that were raised by other modules, which should make the whole error handling a bit more streamlined within EVerest. The EVerest Core July 2023 release will have the aforementioned extended OCPP 2.0.1 support. There is now a SLAC implementation for the EV side in EVerest Core, and we already merged the module subdirectory support because we want to restructure how the modules folder within EVerest Core looks like. And this is where we also want to have your opinion. We created a short questionnaire that you can hopefully fill out and give us some feedback on how you would like this module folder to be structured. You can choose between one of two options there, but there's also a free text field if you want to give some general feedback. That would be really appreciated. And now, what's next? Let's have a look at the roadmaps. I'll just go into the short-term Q3 and Q4 of 2023. We want to have an OCPP 2.0.1 implementation and start with 2.1 as well. Have a C++ based EXI parser and parser generator that is ISO 15118-20 capable. And yeah, some details on the next slide to that. With the OCPP timeline, what's the state right now? OCPP 1.6 is fully implemented and tested, and there is a basic 2.0.1 implementation coming up. We'll have a subset of messages for to be able to get like a core certification possibility, things like authorization, configuration, transaction support, the remote control, and the security. In Q4, we then want to experiment with the bidirectional power transfer support from OCPP 2.1 and also play around a little bit with this OCPP error code harmonization that was proposed. At the end of the year, we hope to get more or less most of the rest of OCPP 2.0.1 implemented. So we would be on track to have a full and stable tested version of OCPP 2.0.1 within the first within the first half year of 2024. And on the ISO 15118 timeline, what we have right now is a fully tested and operational ISO 15118-2 and DIN-Spec 71-1 implementation. We also have proof of concept for bidirectional power transfer based on the C++ implementation by ChargeByte and Pionix right now. What we're planning in the next couple of weeks is to put a bit of work into the Joseph Community Edition based -20 for the EVSE side, for temporarily, just so we have something to play with, but also more on the car side, so we extend our simulator, which we will probably also keep in the future. And then in the fourth quarter of this year, we would like to implement the ISO15118-20 DC bidirectional power transfer proposal from the SAE. And at the end of the year, we want to have a C++-based replacement for Joseph on the EV side, as well. And next year, we want to have DC bidirectional power transfer and AC bidirectional power transfer available as well. Just some upcoming events where you can find some of us from Pionics or from ChargeByte. Will be at the Chaos Communication Camp in August in Brandenburg. We'll be at the ICNC the end of August in Berlin, and we'll be at the Drop in Malmö in Sweden at the beginning of September. We'll also be at the next OCPP Plugfest in Arnhem at the end of September. Probably will be at the Charan USA event, but there it's not really clear when that will happen, probably in Q4 this year. But we will definitely be at the one in Valencia in October, and there will be an EVerest summit sometime, probably in October this year. We'll like I just mentioned, next event will be the Chaos Communication Camp in August in Brandenburg, in the Ziegeleipark Mildenberg, middle of August. Probably if you don't have tickets until now, you probably won't get any more. But if you have tickets and are there, we will gladly chat with you and maybe hack on some cars and chargers together. The next TSC will then be just a week after the Chaos Communication Camp on the 24th of August at the same time as today. And in the meantime, you can also join our public developer call every Tuesday between 3 and 4 p.m. Central European Summertime. And now I would like to go to the discussion part and stop the recording.